Section 5.4, Properties of Logarithms. Okay, so by now we have an idea of what logarithms are. There are some properties of logarithms that we need to know before we can get to the logarithmic and exponential equations. Okay, so let's talk about the first one. First major one here would be what's called the product rule for logarithms. And it's called that because if you are given a product, right, where it's something times something inside of a logarithm, well, you can actually rewrite the entire expression as a sum, as an addition problem, and preserve the value, right? Just make sure that you keep the base the same, right, throughout, and you can write it out as an addition problem. It's the same thing. Okay, and so how does that look? Well, if I said to expand log of 0.2x, right? Remember that 0.2x is inside the parentheses there, right? It's inside the logarithm. Think about that as a function, not multiplication, right? It's like f of x. It's kind of that notation there. Okay, anyway, if you had that, you could write it out in expanded form as log of 0.2 plus log of x. You know, that might be helpful. Or perhaps you are given something that looks like this, natural log of a plus natural log of b, and you wanted to write it in a more consolidated form. You could say, well, this is a product, natural log of a times b inside of a single one, right? That's just this one in reverse. Okay, so that's two different ways you can use that one property. Okay, another one that's pretty useful is called the power rule for logarithms. And it looks like this. So you have log base b of something raised to a power. I'm going to use the letter P to represent power here. Okay, well, you could actually rewrite that as log base b of the number inside without the power, but you multiply the entire thing times that power. Okay, so it's a way you kind of think about it. You take that exponent and you bring it down into the front, or you can bring it behind. Doesn't really matter. But it becomes a multiplication problem. So it takes exponents and turns it into multiplication. So how does that look? Well, you might have something like log base a of x to the fourth power, and you want to write that in a more simplified form, at least in terms of exponents. So you could do that as 4 times log base a of x. Okay, that's a little bit easier to work with sometimes. Okay, or again, you can do this in reverse. Let's say you had negative 8 log base b of q. And you want to write that as just a logarithm with everything inside of it. Okay, well, that would be log base b of q to the negative 8 power. Okay, if something's multiplied times that logarithm, you can use it as the exponent. Okay, a third property, pretty useful property here, is the quotient rule for logarithms, and it's very much like the product rule. If you have a fraction, right, or some division going on inside, or if you can imagine that it's there, right? And when I say imagine that it's there, if you had something like log of 10, you could write that as log of 20 over 2, right? You can imagine that there's division there. Okay, anyway, sidetracked. If you have a quotient, you can write that as subtraction. Okay, so it's very much like the product rule with addition. This time it's with subtraction. You'll often see that these are put together sometimes. There's ways to write it out where it's all at once. Anyway, that doesn't matter. Okay, so let's do an example. So example 5 here. Let's write out log base b of 76 over 13. Let's say I want to expand that out. That'd be log base b of 76 minus log base b of 13. It's really not difficult, right? You're just applying the rule. Or let's go in reverse here. Let's say I had natural log of a minus natural log of b, and I didn't want to deal with all those natural logs, and I want to write it out as 1. Well, I can write that out as natural log of A over B. Okay, that'd be the quotient rule. Okay, so those are the 3 main properties that we're going to use. Okay, so let's kind of talk about and tie this together with inverse functions. Remember, we talked about inverse functions. A function and its inverse, if you composed a function with its inverse, right? In other words, you plugged a function into its inverse, they cancel each other out to leave you with x, right? Oops, wrong button there. X. Same thing is true if you compose it the other way, right? If you compose it this way, that means f with f inverse plugged in, that gives you x, right? This is section 5.1. Okay, well, remember, an exponential function and a logarithmic function are inverses of each other. So if you plug an exponential function into a logarithmic function, if you plug the right ones in, they will cancel each other out. And that's the next point I want to make here. And that's these properties right here. So if you have log base b, and inside you have b to the x, right? So logarithmic plugged inside that logarithm is an exponential with matching bases, right? The bases have to be the same. Well then, just like with inverse functions, those would cancel each other out and leave you with x. Okay, so that's a property you want to remember. Likewise, if you have an exponential, let me give myself more room here. If you have an exponential and its exponent is a logarithm with a matching base, where x is plugged in, again, the exponential term and the logarithm will cancel each other out and leave you with the x that's on the inside. Okay, so these are very important. We're going to use these when solving exponential and logarithmic equations. Okay, they're actually really easy to use. So logarithms and exponentials are inverses of each other. Now, each of these lead to special cases, right? So let's talk about some special cases real quick, just to keep in mind. If you don't remember the special cases, it's not the end of the world. You'll figure it out as you're working through it. You'll just figure it out because it works out that way. So, special cases. Log base b of b. In other words, if you had something like log base 5 of 5, right, where the numbers are the same. Okay, well, if you think about that, those would cancel out. So what's left? Well, what would that exponent be? Understood 1 up there, right? Understood 1 on top. So that would be 1. Anytime you have a log with the same base as a number inside, it equals 1. Okay. Also, if you have log base b of 1, this one's a little trickier. Log base b of 1, or log base anything of 1, right? That's what the b means, anything. Well, remember, you know that anything to the 0 power equals 1. Anything to the 0 power equals 1. So what if we said that 1 is b to the 0 power, right? Let's just say that this 1, we're kind of making that up, right? We know anything to the 0 power is 1. So we're going to kind of cheat a little bit and say, well, let's say it's b raised to the 0 power. Okay, well then what happens? It equals 0, right? Okay, so we can actually cut out that middle person right there. So log base b of 1 equals 0. And that's true for any base, right? So natural log of 1 equals 0. Log base 14 of 1 equals 0, and so on. Okay, so those are some special cases just to keep in mind. All right, so now let's go to another type of problem. And for these, we want to try to keep all of the rules in mind. So I want to write out log base b of x squared y over b cubed. I want to write that out in expanded, simplified form. Okay, so there's a lot going on here, and you really can just take it one piece at a time. I will do this in a couple of different steps. So the first thing I'm going to do is recognize this is a fraction, right? A quotient, a top and a bottom. That's the first thing that I see. So I'm going to actually use the quotient rule here and write it as subtraction. So this is going to be, let's say the top is red, log base b of x squared y minus the bottom log base b of b to the third power. Okay, hope that makes sense, right? That's the quotient rule. You change a quotient or division into subtraction. Okay, great. Now, take this one piece at a time. This red piece on the left has multiplication inside. That's a product, so I'm going to use the product rule, which just means to write this out as a sum, as addition. X squared plus log b of y minus, what happens here? Yeah, look at that. The bases match. They cancel out, leaves me with a 3. Okay, almost done, right? Not quite, but almost done. I see I have this exponent here. Remember the powers rule. I can take that exponent and bring it down to the front. So I'll do that. This is going to be 2 log base b of x. I don't need those parentheses. Plus log base b of y minus 3. Okay, took care of the fraction first, then the product rule, then finally the quotient rule. Do another one, a little trickier than this one. Log base c of the cube root of y cubed z squared over x to the fourth. Let me kind of make sure that that covers all of that. All right. Well, we mentioned it last section. Whenever you're dealing with a cube root, remember that that is the same thing as raising something to the 1/3 power. So I'm actually going to take care of that first. I could take care of it later. If I wanted to, I could multiply this 1/3 times each of these exponents and simplify it from there. But I'm just going to take this using the power rule and bring it down to the front. So this is going to be 1/3 log base c of y cubed z squared x to the fourth. Okay, so that 1/3 is actually times that whole thing. So anything that I do with the logarithm, I'm going to have to multiply times 1/3 when I'm done. All right, so let's work with it. Let me give myself some more room here. So 1/3 times, give myself some room to work. Just like the last problem, I see a quotient, so I'm going to do subtraction. Log base c of y cubed z squared minus log base c of x to the fourth. I'm going to scooch on down to the next page here. 1/3 times, I see I have multiplication here, or product, so I can write that part as a sum Okay, now all that's left to do is take care of, well, maybe not all that's left to do. One of the next things that I can do is take care of those exponents by bringing them each down to the front. So this will become 1/3 times 3 log cy plus 2 log cz minus 4 log cx. Okay, and then let me distribute the 1/3. 1/3 times 3 is 1. 1/3 times 2 is 2/3. 1/3 times 4 will be 4/3. So my final answer here is 1 log cy plus 2/3 log cz minus 4/3 log cx. All right, there we go. So that was a little bit more complicated version of the last problem. Okay, so that's expanding logarithms. Let's go the other direction. Let's simplify some. So here in this example, example 9, I want to simplify ln 54 minus ln 6. If you have two logarithms that are being subtracted and they have the same base, like these two have the same base e, then you can write it as a single logarithm with division or quotient. And I can actually simplify that, right? 54 divided by 6 is 9, so this is just natural log of 9. All right, consolidated that pretty nicely. Let's go on to another example. This one's not as nice. Log, no base, so it's understood to be 10 of x cubed minus 8 minus log base 10 of x minus 2. This again looks like a quotient problem, so let me write it as a quotient. This is the same thing as log x cubed minus 8 over x minus 2. And maybe you don't spot this right off the top of your head. Maybe you do. Hopefully you do, just because it make your life a little easier here. X cubed minus 8 is actually this difference of cubes, which will factor as x minus 2, x squared plus 2x plus 4. It's a little formula. Look up difference of cubes if you don't remember that formula. It's not one that I think you have to necessarily memorize, but it wouldn't hurt. All right, anyway, so the top will factor to be that. So I'm actually going to write that out. So x minus 2, x squared plus 2x plus 4 over x minus 2. The reason why we wrote it out that way is because you may see that those two things will cancel out. And so what's that going to leave me with? Log of x squared plus 2x plus 4. That's the simplified version of this problem. All right, there is one other type of problem I want to go over, and this one's more for fun. So, all right, anyway, we're given some information here. We're told that log base b, we're not told what b is, but log base b of 2 equals 0.693. We're told that log base b of 3, same base by the way, equals 1.099. And we're also told that log, same base, of 5 is 1.609. We are asked to find, given that information, for the next two examples, find log base b of 30. All right, and this one gives people a lot of trouble at first, but let's just think about what's happening here. 30 by itself means nothing, but what is 30? You can write 30 in a variety of ways, right? 30 is the same thing as 30 over 1, 300 over 10, right? That's different ways you could write it out. It's 2 times 15, yeah. It's 2 times 3 times 5, right? Because that's 15. It's 2 times 3 times 5. Hey, that's a product, right? And it happens to be these three numbers. So I bet that has something to do with it, right? Let me rewrite it. Log base b of 30 is the same thing as log base b of 2 times 3 times 5. Right? 2 times 3 times 5 is 30. That's a product. The product rule says that I can just add all those together as separate logarithms. Don't need the parentheses. Well, that happens to be what these three things are, and I know their values. So I'll add those three together. Log base b of 2 was 0.693. Log base b of 3 is 1.099. Log base b of 5 is 1.609. I can add those three things together and get 3.401. I think I did that right. So I can find the value of this thing by knowing these, using the properties of logarithms. All right, let's do one more. Example 12. Let's find the value of log base b of 15b, given the same values that were above. Okay, well, I can write this out as 15 is 3 times 5. So let's make that into a product. Log base b of 3 plus log base b of 5 plus log base b of b. That's one of our special cases. All right, so log base b of 3. We're told that log base b of 3 was 1.099. You can see that up here. All right, 1.099 for log base 3. Log base b of 5 was 1.609. So I'll substitute that in here. And we're not given log base b of b, but remember, that's one of the special cases. If you think about this as an understood 1 up here, those two things will cancel out. That'll leave me with a 1, right? So 1.099 plus 1.609 plus 1 should be 3.708. All right, so that's just another type of problem that you can find or solve, right? You can find the value of that logarithm given the values at the top and with the properties of logarithms. So there we go. We got some special cases. We got the product rule for logarithms, quotient rule, and the powers rule, and that would be the properties of logarithms.